So till example number 5 is over, we are moving to example number 6. So example number 6, sixth example. Sixth example is also talking a little bit of, we are moving out of the box and we are learning. We have a surface like this one. Okay, this is also a kind of pulley systems. So we have a pulley fixed here and a pulley is connected here. Here I placed one block, M2 block, and over this one I have placed another block, or let me consider this as M1 and this is considered as M2. Okay, I am assuming M2 is greater than M2. M2 is much greater than that of M1. Okay, so we need to do something else will be here, right? How to find out how we can do that factors. Okay, this is something like this is another model of problem, another model of example. This kind of inclined plane, it's called, normally this is called a wedge, W-E-D-G-E. This is called wedge. Okay, here we want to know little bit of vectors. I'll tell you what is called vectors. Okay, remember one thing, normally in school classes you have learned, if this angle is theta, okay, this is called adjacent side, this is called opposite side, this is called hypotenuse. Okay, Pythagoras theorem. Okay, so adjacent side, opposite side, hypotenuse, all these things. What is cos theta in trigonometry? Cos theta is adjacent side by hypotenuse. So ADJ divided by HYP, hypotenuse. So what is, I can say, ADJ, adjacent side will be equal to cos theta into hypotenuse. Okay, adjacent side will be equal to this one. Similarly, if I find sin theta means what? Opposite side divided by hypotenuse, right? This is a mathematical principles. So what is opposite side from here? Sin theta multiplied with hypotenuse. Okay, these two equations you have to remember always. This is very important. Throughout my journey for the physics, I will use this in various places. What you want to remember while we are seeing this problem, if theta, this side is very closer to theta, right? This side is very closer to 3 theta. Whatever I am shading here is very closer to theta. If it is very closer to theta, then you have to written as cos theta into hypotenuse. Hypotenuse is hypotenuse. If something is coming opposite to theta, you have to written as sin theta into hypotenuse. Whenever you see something adjacent to theta, then you have to write cos theta into hypotenuse. Whenever you see something opposite to theta, then you have to see sin theta into hypotenuse. One conditions are there. Wherever you write cos theta into hypotenuse, wherever you write sin theta into hypotenuse, these two sides makes how much degree? 90 degree. Okay. So the sides nearer to theta is called cos theta, the side opposite to theta is called sin theta, but one condition, these two sides, wherever you are marking, these two sides are perpendicular to each other. We will make another example. Suppose I have two lines like this. Okay, two lines like this, and these two lines are perpendicular to each other. Okay, we will see with the problem itself, so that will be much easier. So note on this point, this is very important. This is very important. This is very important. This is very important for me. This we will use it everywhere. Okay, so hope you have written. Okay, so let's continue. Let's continue the journey. Okay, what is our journey? Okay, so first I will draw the free body diagram of this one. Okay, then we can use our shortcut formula here, but before that we have to learn something. So this is the case, right? This angle is called theta. This side is what? M1G. Weight is always acting pakka like this. Okay, and if this side is theta, what is this side will come? 90. What is this side will come? 90 minus theta. Okay, so this is the side. Okay, this is one side, this is the another side. So now we have a triangle. So this is 90 minus theta. So what is this component of force will come? So this is like an adjacent side. This is like an adjacent side will be here, right? This is not 90 degree. This is 90 minus theta. This is 90 degree. Okay, so what is this side will come? So we have to draw two sides. One is this line and another one is a perpendicular line. So two lines I have drawn. Okay, two lines I have drawn. One is this line and another one is this line. Now these two lines makes 90 degree. So what is this side will come? This side will come m1 into g. m1 into g into the side nearer to theta. Here instead of theta, what is there? 90 minus theta. So cos of the side nearer to theta is called cos theta. But what is theta here? 90 minus theta. So 90 minus theta. So this is one side. So we need another side which is making 90 degree with this side. So that is this line. This line is coming what? m1g into the side opposite to theta, and which is also making 90 degree with the cos side. This is a cos side. So this side is making 90 degree with that. That is called a sine. So sine of what is the angle for theta? 90 minus theta. So what is cos of 90 minus theta? Cos of 90 minus theta is m1g into sine theta. What is g? Sine of 90 minus theta? m1g into cos theta. Okay, hope you got the explanation for this one. I have m1g is like this. I drawn two lines. One is this line. This is nearer to cos of 90 minus theta. So the near line is called cos 90 minus theta. This is one line. And I have drawn another line perpendicular to this line. This line I have drawn. This line I have drawn. This is perpendicular to this line. This is one line and this is perpendicular. So the perpendicular one is called sine of 90 minus theta because it is not nearer to 90 minus theta. The 90 minus theta is nearer side is called cos. So the other side is called sine. Sine of that angle. 90 minus theta. This is what we have done here. Okay. So in short, in this diagram, I can just mark. This is called m1g. This is called m1g. And I have two things will be here. One is this line and another one is this, another lines will be here. And this side is called, what is called m1g cos theta. m1g called cos theta. And this one along this line is called m1g sin theta. Always remember like this. If this angle is theta, based on this angle we are saying m1g sin theta, and this perpendicular one is called m1g cos theta. Whenever you see here onwards, today onwards, this moment onwards, whenever you see some diagram like this, blindly mark this is called m1g sin theta, m1g cos theta. What is the value of theta? Theta is this angle, not this angle. Sometimes to confuse the question, they will give you this theta equal to 30 degree here. So what is our value will be here? Here it is 30 degree means this is 90, right? So what is balance will be here? 60. Total angle of a triangle is 180 degree. So this is 60. So 60 has to come here. Okay. So now we have to apply our formula. Acceleration is what? Tell me. Forward force minus reverse force divided by sum of the masses. What is forward force? m2g's block is moving downward. If you are assuming like that, okay, there are chances this is also going downward. So now I am assuming m2g is moving downward. If your assumption is correct, you will get a is a positive number. If your assumption is wrong, then you will get a negative number which indicate acceleration in the opposite direction. That's all. So you don't want to worry about the direction. Forward force means m2g like this. This is the direction. So forward force is m2g. So the reverse direction is what? Reverse direction is m1g sin theta minus m1g sin theta. m1 whole divided by m1 plus m2. That's all. This is a formula for acceleration. Now we have to go to find out what is called tension. Tension is, tell me, forward force into reverse mass plus reverse force into forward mass whole divided by sum of the masses. What is the forward force will be here? Forward force means this one, right? I am assuming this is moving downward. In that assumption, m2g into reverse mass means what? m1. So m2g multiplied with m1 plus reverse force, this force, reverse directions. That is called m1g sin theta into forward mass, this one, m2 whole divided by m1 plus m2. So what we can take it common outside, m1 m2g, we can take it outside from the numerator. So will come m1 m2g into 1 plus what is coming extra will be there, sine theta whole divided by m1 plus m2. This is our beautiful formula of tension. This is a formula for to find out the value of tension. So acceleration's value you know, tension's value you know, and this is a case of an inclined plane with the pulley. So you can write some subheading like this: inclined plane plus pulley. Earlier we have learned only about pulleys, right? Now we have inclined plane will be there. In addition to that, we have a pulley system is also holding there. This is one case, right? We will see the example number 7. Hope this is clearly understood to you. Pause the video, complete the notebook. Example number 7. Example number 7. Class note is very important, okay? With the class note, you can crack the examinations. Without class note, difficult. Example number 7. Example number 7 is, I have two inclined plane like this. I have two inclined plane like this. And this is an M1 body which is moving over a pulley, and this is another body M2. This angle, you can consider anything. I'm considering as alpha, and this is considering as beta, theta 1, theta 2, anything else, it's fine. And this value is, you know now, right? M1g into sine of alpha. This value is what? M2g into sine of alpha. Okay, and we know one forces will be like this in opposite directions. What is that is called a M1g into cos alpha, and here also we have one force will be here, that is called M2g into cos beta. Cos beta. Okay, this is not alpha, this is beta, right? This side is beta angle, this side is alpha. So these two are alphas, these two are betas. Okay, so we are going to find out acceleration. Our shortcut method: forward force minus reverse force divided by sum of masses. Tell me, forward force. Forward force means what? M2g sine beta. So M2g sine of beta minus reverse force. Idana forward, adukku reverse this directions. So it is M1g of sine of alpha whole divided by summation of the masses. Summation of the masses means what? M1 plus M2. That's all. Over. Tension find out, acceleration find out, tension tell me. Forward force into reverse mass plus reverse force into forward mass whole divided by sum of the masses. Tell me, what is the forward force? Forward force means in this directions. So M2g into sine beta into reverse mass means what? M1 plus reverse force. This force is actually in this direction, but when it is moving downward, this force will get reversed. That's all. So M1g into sine alpha, reverse force. Forward mass means what? Multiplied with M2 whole divided by M1 plus M2. Will simplify. What are the terms? We can take it outside from the common terms. M1, M2g, correct? M1, M2g. So what will come? Sine beta plus sine of alpha whole divided by what will come? M1 plus M2. M1 M2g into sine beta plus sine alpha divided by M1 plus M2. You can check whether I am doing is correct or not. You can refer any of your textbooks, any of your materials if you have any, but it is, I am sure this is pakka correct. So M1 M2g into sine beta plus sine alpha whole divided by M1 plus M2. You can go with your standard method, but that is very time consuming, right? So tension is where? Tension is acting on this rope. Here we have the tensions will be, it's the same rope, so same tension. Okay, so you can derive in a normal method also. You can take the free body diagram of M1. So M1g sine alpha, tension, and M1g cos alpha. Here we have something called what? Called reaction. Here also you can also mark something called reaction is making 90 degree with the surface. So N1 will be here, and okay, this direction is like this, and we have N2 will be here. Here you have two directions. So if you are taking the free body diagram of the first mass M1, what all things you will mark? Tension you will mark upside, downside what you will mark m1g sine alpha, and here you will mark m1g cos alpha, and here you will mark n1. Okay, this is one method. And for m2 also you are using the same method itself. n2 m1g m2g cos beta, tension m2g sine beta. But here you have a confusions may arise. What is upside, what is downside? Whatever is going in this direction, upside is like this, right? So whatever is so now you are listen, now you are positive y and plus x like this, and minus x like this, and minus y like this. Okay, so whenever an inclined plane is coming means what you can do means you can just rotate this axis. So what you will get, plus y minus x and plus x and minus y. So you can just keep it here, these lines like this. Again, plus y and minus y and plus x and minus x, which means what is going upside is positive and what is going downside is negative. What is going in this directions downward, it's negative. What is going in this direction, here n2 is positive but m2g cos beta is negative. Here we can write a formula. What formula will write? n2 minus m2g cos beta is equal to 0, because the block is not moving like this. But if you are writing these equations like this, how you will write here? Positive. So t minus m2g sine beta is equal to acceleration. Acceleration is negative. So what you will write? Minus m2a you will write. Okay, so that is a way of writing the free body equations, and to solve it you will get a couple of equations. Here you will get two equations. One is in the y direction, another one is in this x directions. Okay, similarly you will get x direction equations here, sorry, y direction equation, and x directions equations will be here. You can use any of these equations. So you will get two equations here, two free body diagram, two equations, you can solve it. But it's not really required. If you know this formula, this shortcut method, you can able to answer this question. But as I told before, everywhere you cannot use it, but there are some limitations and some cases are there. So just for your understandability, now we know the formula, we know the equations, but we'll just draw the free body diagram of M1 for your better understandability. Free body diagram of M1. I know, you know, but still we will write. Okay, M1, and this is called M1g of sine alpha, and this is called a tension, and we have one force will be here, M1g into cos alpha, and we have a normal reaction N1. In this case the block is moving upward because it's moving like this. Now can you tell me the formula? T is upside, so T minus downside is m1g sine alpha is equal to acceleration is upward. So this is called M1a, equation number 1. So what is N1 is positive, so N1 minus m1g into cos alpha is equal to 0 because the block is not moving in this directions. Okay, so we got two equations for this one. I am clearing the board. I am going to draw the free body diagram of M2. Okay, so you can pause the video and you can complete the notebook. So going to draw the free body diagram of M2, the second body in the free body diagram. So the block is look like this one, and this is called M2. And what is this force? We know M2g sine beta, and we have something called a tension in this direction, and we have something called m2g into cos beta in this direction, and we have the normal reaction. Normal reaction is always making 90 degree with the surface, 90 degree, pakka 90 degree with the surface. So acceleration is in this direction. So we will write the equation. T is upside, so T m2g into sine beta is equal to m2a, acceleration in the downward direction, so minus one equation. Okay, and the second equation is like this one. So N2 is positive, N2 is going like this upside, so N2 minus m2g cos beta, m2g into cos beta, and the block is not moving in this direction, right? Block is moving only acceleration in this direction, no acceleration in this direction, so it is equal to 0. Two equations will be here. You can solve these two equations with the free body diagram of M1 two equations, and you can find out the value of tension. You can rearrange the equations and you can find out the value of tension you can find out the value, because the second equation of this one and second equation of the free body diagram of M1 is not required, because it's not contains acceleration, not contains tension. Only the first equation of M1 and first equation of M2 will contain acceleration. So what you can do, you have T will be here, you have T will be there. So T, you can add these two equations and you can subtract or you can add, and you have to find, you can solve these two equations basically, and you are finding the value of tension and you are finding the value of acceleration. Once you got the value of tension or acceleration, you can substitute in any one of the equations and you can find the value of the other quantity, as like we have done it for example number 4, I guess, for pulley system. Now we are at example number 7. Okay, if you do the same method, if you follow the same method, you will get the answers whatever we have get it for the shortcuts method also. Hope you remember. This is just I written for your reference purpose only, the free body diagram, but whenever we have a shortcut method is available, we can use that method to make your life easier and to score the higher marks. Okay, hope till example number 7 it is clear. We have still some more will be there. Okay, so let's continue with the next example. Example number 7 we discussed, right? So next example number 8. Okay, so now we know the shortcut formula to find out the value of accelerations and to find out the value of tension also. So 7 different category of models we have seen. We are moving to the 8th model. Okay, 8th model is more or less similar to what we have seen, but there is a slight difference will be there in this model. Okay, so all models are working in certain fashions, but there are some difference will be there. Now we have learned about concept number 1 and 2, and which is related with what is called contact force and tensions. Now this is another model. This is giving a concept of the third rule. Third rule means what? Tension into acceleration is constant. The third rule we are going to see will be here. We have a fixed structure and we have a pulley system will be here, and over the pulley we are connected another pulley. This is like a multiple pulley system, and it is connected like this, and we have something called something like this. Okay, so this is a mass of M2 and this is a mass of M1. I am assuming M2 greater than that of M1. In this case, if M2 is greater than that of M1, in this case what will happen here also, the question is as usual, it is obviously the same question. What is the value of accelerations, and we need to find out what is the value of tension in this context. Question is simple, but here the thing is like this is an example. You will never get a question exactly like this. You may get in different structure, but the concept is simple. Here this is a fixed pulley. Fixed pulley means the pulley cannot move as such. It is fixed here, but this is a movable pulley. This is a movable pulley. So you may get any model, but this is one example. So here if M2 is greater than M1 means M2's acceleration is like this and M1 will move upward. Before that we have to always mark with the something called the tensions. We'll mark the acceleration tension here. If you get something, some model of question will be like this, not like a, this is also like a two body, but there is a two pulleys are there, not like a simple question, little one step advanced one. In this case what you have to do means you have to mark this called tension. So the same tension is available here, same tension is available here, and the same, because it's a same rope, so same tension is available. These two tension together you will got another tensions called 2T. Tensions are always away from the body. Now this is your first step. When you got a questions like this, first you have to mark a tension. So I am writing how to solve the problem. So first step is always mark tension. Okay, tension forces. So you have to mark the tension forces. Second one, mark accelerations. Mark acceleration. Mark acceleration in the sense here I am assuming the body will have an acceleration. We know it is going down, right? So with an acceleration A. Then what you have to do means this body will also move upward with certain accelerations, right? That concept you know definitely this is going down means this has to go upside. But here the point is like, if you multiplied T and A, what you will get? You will get TA, that's all. And TA is constant. If you are getting TA here also you need to get a TA. But if you multiply 2T, so 2TA is constant, which means 2T into, if you need to get A will be here, what you need to multiply? You have to multiply it with A by 2. So this is called A by 2. This is the logic. Okay, so which means you have to draw the free body diagram of M1, you have to draw the free body diagram of M2, and you have to find tension and acceleration. Question is asking what is the tension of M2 body, then the value is T. T value you will get it. Sometimes question will ask what is the value of the tension on the string of the M1 body is connected, then what is the value of tension? In that case it is 2T. So T value you will get it from the answer, but you have to give answer to the question is 2T. Another way of asking, what's the acceleration of M2? You will get it as value of acceleration A. So A is your answer. And what is acceleration of M1? M1 acceleration is A by 2. A value you will get it after drawing the free body diagram, after writing the set of equations, but you have to give an answer will be equal to A by 2. So let's move forward. We will just draw the free body diagram. Now once you mark everything, things will be quite easy. We will draw the free body diagram of which mass? M1. Free body diagram of M1 I am drawing. So M1 weight downward Tg and tension is 2T and acceleration is upside. So it is A by 2. Now we can write the x, there is no x equations, okay, but only like this. So only we have the y equations. We will write the y equations. So what will be the y equations will be here in this case? 2T is upside, so 2T minus M1G will be equal to M1 into A by 2. You get equation number 1. Okay, and what you have to do next, we'll draw the free body diagram of second mass M2 here of M1 and free body diagram of M2. Can you tell me M2? Now it is easy. Now you know how to do it, right? M2 is a body and whose weight will be equal to M2G and its tension is equal to T and acceleration is equal to A. Now we can write an y equation here also. What is the y equations here? What is the y equation here? T minus M2G is equal to minus M2 times of A. This is your equation number 2. What you have to do? You have to solve these two equations and you have to find out what is the value of T and what is the value of acceleration. I am not solving here. If it is in a real numerical problem, it is easy to solve because M1 and M2 value will be given. You can substitute here G while you are solving the problem. You have to take in G is equal to 10 meter per second square. So in this case G will be equal to 10 meter per second square. Okay, this is the core concept. So normally especially for IIT main examination and AIMS kind of examination, this is little more difficult than maybe some NEET examinations point of view kind of examination. So all India level entrance examination, this is a kind of tricky question. Students will feel very difficult, but it is easy. We have two rules: mark the tension, mark the acceleration. Then once it is done, what you have to do? Free body diagram of M1 mass and free body diagram of M2 mass, you have to do it, and that is a final ultimate step of this one. Okay, and there are other way of defining this concept. Okay, maybe if you are referring some reference textbook, there is also one concept will be there. You can see here this body is fixed connected. Okay, the body is fixed connected. I will take another pen, so which will be more clear. So this body is fixed connected. Fixed connected means there is no acceleration. So here acceleration is equal to 0. So this rope will have an acceleration of A. So this acceleration is the average of these two, which means that what? So if this acceleration, so acceleration of M1 body is average of these two means 0 plus A by 2, which is equal to A by 2. Some textbooks, some reference books are also mentioning like this. So it's up to you how you are remembering. So for me, normally it is very easy. TA. Here also we need to get a TA. In order to get a TA means T become 2T. So A become A by 2. Then only we will get TA on the this side and this side. So you can use it any method, that is up to you. Okay, here you can take the average and you can mark it like this also. But normally I am using tension into acceleration as a constant, which will be very easy for me to always to get an answer for our question. So you can also follow that method. So maybe if you are referring in future also, now definitely there is no chance you are go and refer this book when you are in 11th standard, but once you are keep on reading something, and if you are getting some good informations during that time, there is a chance you may go for other reference book textbook, but you may see this kind of logic also will be applied there. Both are one and not the same. So we'll move to next set of example. Example number 9th. So 9 different cases, right? So all these are, this is a very interesting chapter, much far better than, like, not better than, like, many interesting things will be there. You can play if you really know, and you can answer it in a very real fashions. So we are going with example number 9. Example number 9, I'll give a structure like this. Okay, this is a mass which is connected here, and this is over a pulley which is connected here, and this is a round path, and here also we have a something called some mass is connected here. Okay, here also one mass is connected, and here also we have a pulley system is there, and both ropes are coming together. So this is a fixed end, so it is finalizing here, and we have a pulley system will be here. Over here I have attached another mass. This mass I am giving as M1, this mass I am giving as M2, and this mass I am giving as M3. Okay, so now there are different things will be here. There are again 3 mass systems are there, but this is one rope, right? This is one model. So here I just want, here I am not going to the equation level also we can do it, but I just want you to get into these concepts clearly. I will draw one more set of diagram similar to this, but it's slightly different from what you have seen here. So this is a fixed rope, and here to know the difference, okay, how it is getting difference. So here M2 with the same M2 I am keeping it here, and this is also fixed pulley, and we have a movable pulley, and over the movable pulley I am placing the next mass called M3. Okay, so the surface are fixed. So what's the difference you have seen between these two? Well, if you are seeing this set of diagram, the difference here is, here it is fixed, here it is M1 mass. Okay, so it doesn't matter, we will mark the tension. So what is the value of tension? This is called tension, and this is also called tension, and tensions become 2T. Okay, suppose I am assuming M3 is very bigger one, so everything will going down. So this is moving with an acceleration of A. So what is the tension of this one? T. So 2T into A. Okay, so 2T into A is will be here. Here we have tension. So what will be the acceleration in this case? Accelerate T comma 2A, because we need to get 2TA. So any one side should be compensated. So here if it is T, then what we need to get 2TA. So what is accelerations? 2A will be here. This is one factor. Here in this case, if you see, will be here, this body will have a tension T, the body will have a tension T. What is acceleration here? Acceleration here is 0. Here we have a tension of 2T. So what is acceleration? I am assuming the accelerations will be equal to A. For example, I am assuming the acceleration is equal to A. So here its tension is T and accelerations become 2A. Okay, now if you see, whatever we have marked here is A. So this is fixed, this is horizontal, and we always will be getting the average of these two. Okay, so in this case we have M1 body is not here, but M2 body will be here. So M1 body is not there, but M2 body will be here, but M2 will be there, M3 will be there. We are just marking the tensions. We are applying rule number 1. Here we have a tension, and here we have a tension of 2T. T and T together will comes 2T, and I am assuming the accelerations will be equal to 2TA. So 2TA, here it is equal to 0. Okay, because accelerations will be equal to 0. There is no connections to this one. So if it is fixed end means acceleration is going to 0. There is no accelerations. So this is just a model I just depicted to know the difference between acceleration is equal to 0 and acceleration is not equal to 0. Just a model only, nothing. I am not going to the equations level. We'll go into example number 10th example. Okay, 10th example is also similar to this one. Here we are going to see the connected bodies. Connected bodies means similar to the one what we have learnt before. The same like a tabular kind of structures. But here what will happen means one body is connected here and another body is over a pulley. These are the different models, nothing to worry, because wherever you go you have to mark M1 and M2. I am assuming M2 greater than M1. Any type, any model you can ask, but ultimate aim is you have to mark the tensions and you have to find out the value of tension and accelerations. Okay, so here we will mark. So here in this case we need to mark the tensions, we need to mark the acceleration. So this is called a tension and this is called acceleration. So TA, the same rope will be there. So with respect to this body also there is tension will be here and there is accelerations will be here. You can draw, you can write the free body diagram also. So just we will write free body diagram of M1 body, M1. So like this, and we have a tension like this, and we have an accelerations like this. No other things, right? No other forces are acting on the body. Weight will be there, of course. Weight will be there M1G and reactions will be there N1. So X set of equation is what? Minus T is equal to minus M1A, which is T is equal to M1A. In Y set of equations, minus T means left side, minus A. Y set of equations, N is upside, so N1 minus M1G is equal to 0. That's all. Now if you do the free body diagram of M2, if you see any diagram, you have a capability or you have a confidence to draw, oh okay, this diagram I can draw. Such confidence has to come. So this is M2G and its tension is T and its acceleration is A. So I will write T minus M2G is equal to minus M2A. This is another set of equations for free body diagram of M2. So you have this set of equations and you have to solve this part. So any model of questions might make comes. So depends upon that you have to answer. If this end is fixed, there are chances will be there. This end is fixed. Whenever you see a fixed end, nothing to do will be there with the accelerations. All other cases like you have to consider like a tension into acceleration is constant if it is a multiple, or if it is something like you can say a complex kind of systems are coming, then this is the logics behind this one. Okay, so 3 rules has to be remember. Tension into acceleration is constant is one of the cases, and another cases is tension is away from the body and contact forces are away from the body. Okay, so there is another model we will see, the 11th model. Totally we have 12 models, so we'll go to example number 11th. In example number 11th also we have a table and we have a pulley and we have connected a mass, and this mass is given as M2 and we have a rope and this rope is fixed here and we have a pulley here, and over the pulley this is going and we have another mass called M1. I am assuming M1 is greater than that of M2, so acceleration is like this, tension is like this. The same tension is applicable here also, right? Same tension, T will be here. Okay, and here also the body will have some tensions will be here and the body will have some accelerations will be here, and this acceleration is converted in this rope also. So tension into accelerations will be there. Here accelerations will be equal to 0. So you don't want to consider this rope at all. So accelerations will be is equal to 0. So in this case, what is acceleration of this body will be equal to here it is the same rope and here it is not contributing towards an accelerations, but here you have tension and accelerations. You have to draw the free body diagram of M1. T minus M1G is equal to minus M1A. Here also for M2 you have to, here the acceleration is like this, correct? If this body is moving means this will be pulled like this. So you have to consider tension into acceleration constant, tension into acceleration is constant. You have to draw the free body diagram of M1, you have to draw the free body diagram of M2, and you have to solve this one. This is just one model, you can just draw it on your notebook. Okay, then we'll move to example number 11th, not 11th, 12th, last example. This is also a small model, but yeah, just for your understandability drawing. Suppose if you have multiple blocks are given like this, M1, M2 and small box called M3. M1 greater, M2 greater, you can say M1 greater than, M2 greater than M3. Sometimes the questions will come here, questions are coming in two ways. Questions are coming. Okay, so here body will have T1 tension, body will have T2 tension, body will have T3 tension. So the first set of questions they ask you what is the value of T1, what is the value of T2, what is the value of T3. This is one set of question. How we can solve this one? If you are drawing the free body diagram of this one, M3, so we can draw, this is the first model of question. If you are drawing the free body diagram of M3, how you will draw free body diagram of M3? M3 will be here, M3G will be here. Suppose we are pulling it, I'm just take it upward. Means T3 acceleration is like this. So I will write an equations T3 minus M3G is equal to M3. M3 body value will be given. Acceleration value is given in the question, means you can find out T3. Another way, we have now find T3. If you find out T2, how to draw? Either you can draw the free body diagram of M2. For example, you have two methods. Free body diagram of M2. You can draw like this one. So what is the complexity here? If you are drawing this one, means I will tell you T3 and T3, and this become accelerations. If you are suppose if you want to find out T2. Okay, question is asking directly what is the value of T2. So T2 you are seeing with the M2 or you are seeing with the M1. So if you are drawing the M2 body, you can find a T2. So this is one option. Another option is that what? Another option is if you are drawing the free body diagram of M1, T1 value has to find, and here also T2 will be there and body accelerations will be here. This is also an option. And you have one more option is there to find out the value of T2. What is that options? The third option is you can draw a big box. This big box is a combination of these two. Combination of these two means what you can consider? M2 plus M3. So what is the weight? M2 plus M3 into G, and acceleration is upward, and we have T2. I strongly recommended you have to use this method. Why means if you want to find out a T2 here, what you need? You need the value of T3, then only you can find a T2. If you want to find out a T2 value here, you need the value of T1. That is also complex. But if you are combining these two and put it here, and if you are drawing a free body diagram like a combination of two body, then what is the advantages will be here? You don't want to find out unnecessarily T3, you don't want to find out unnecessarily T1. You can directly use this combined free body diagram, and M2 plus M3 value will be given in the question. You can substitute and you can find the value of answer. So unnecessary wastage of time can be avoided if you have an options to club the body. This is one option. So this is way. Similarly, if you want to find out T1, okay, similarly if you want to find out T1, then free body diagram of the whole system you can draw. All the system you can draw means how you say M1 plus M2 plus M3, and what is the weight? M1 plus M2 plus M3 into G, and tension is T1 and acceleration is A. You can do like this. Or other option is like you have to draw the free body diagram of M1. In that case, what you have to do? T1 and T2 you have to mark. To find out a T1, you need to get a T2. So such complexities are there. Such complexities you can avoid if you have an options to combine it, and if you have an options to draw it. So things will be quite easier. Okay, so always think logically. Once you see some questions, if it is completely like a scrapped way, then you can draw one by one. If it is some kind of logic, something like this you can apply, then you can do it like this. But here now if you see in all the formulas, for example in this formula I have written m3a. Why I have written m3a? Because I am assuming the body is moving with non-uniform velocity. That's word is important. While I am starting this laws of motion chapter, I told acceleration is present when the body is moving. What type of motion? Non-uniform motion. Acceleration means v minus u by t. V and u should be different, then only acceleration is exist. Suppose, to confuse you, to make you alert, questions will ask if the block is moving upward with uniform velocity. If you see such question, uniform velocity, then what is the value of this acceleration? This factor is not there in that context. Okay, this factor is not there in that context. So which means, sorry for that, which means if a body is moving with an uniform speed means no acceleration. Whenever a non-uniform field and uniform velocity exists, then accelerations will be there. So while you are reading the question, you have to look for the term uniform. Uniform will be there means accelerations will be equal to 0. So totally almost 12 different types of models we have seen. So always you don't want to remember all these models. Questions may be any other models might be asked. So your contributions to me to the subject is like, take each diagram, understand what it is, try to draw free body diagram yourself, try to find out some equations for that. Okay, tension equation, acceleration equations. This is the ultimate of every free body diagram. And in the end of this chapter, of course, as like what we have done for other chapter also, we will do some numericals. There we will see some kind of questions. If you are some free body diagram logic based questions are there, we will do it with the concept what we have learned. So now this is the fundamentals of or the crux of this chapter. Hope you understood the free body diagram sections. For examples, example number 12. Okay.